Hello everyone, my name's Dr. Paul Rose. This is a quick guide to instantaneous sampling, how we can collect behavioural data from observations on animals at specific time intervals during an observation period. It's aimed to give you the basics in how to do behavioural recording for a project where you might be following a particular individual or you need to follow a group of individuals within a designated period of time. Let's start off with some essential information. There's a whole raft of really good books out there that will go over the basics of behavioural recording in a lot more detail. For example, the Bateson and Martin book, Measuring Behaviour. But this is the essential information that you need to follow along with this worked example in this video. Instantaneous sampling is where behaviours are recorded on predetermined time points. For example, you might have an hour observation period and you are recording behavioural data at 1 minute intervals or 2 minute intervals within that hour period. This enables the collection of behavioural data that can feed into a time activity budget because you are assuming that what you see the animal doing on that 1 minute sample point, for example, is what it's been doing for that entire minute. So you then count up your minutes worth of data, which gives you an estimation of time spent on behaviour. You would do instantaneous focal sampling if you are following a particular individual. You can recognize that individual, so observe it for the full duration of your recording time. Or you would do instantaneous scan sampling, where you count the number of individuals within a group that are performing each behavior in your ethogram on your designated time point. And instantaneous scan sampling is performed when you can't identify individual animals in your group. What's really important about focal or scan sampling regardless is that you must remember that animals can only do one thing at a time. So you don't select multiple behaviours on your sampling points. Animals will only do one behaviour. So that's up to you to describe very precisely what those behaviours are that you're likely to see in your ethogram. So if you're doing an instantaneous focal follow for 10 minutes and you are recording behaviour at 1 minute intervals, by the end of that 10-minute observation period, you will have 10 data points. You don't start recording at time 0, you start recording at the first minute, then the second, then the third, then the fourth, fifth, sixth, seventh, eighth, ninth, 10th, giving you 10 data points, and those behaviours should map what you have already determined you are likely to see based on your background research that goes into your ethogram. So whose behaviour will we be recording today? I'd like to introduce you all to Bruce. Bruce is a red-breasted goose. He is retired from my place of work and he now lives very merrily in his retirement home, which is my parents' back garden, with a range of other duck friends to keep him company. And you will watch Bruce and his behaviours during the course of a 7-minute long video, and within those 7 minutes, on each minute sample point, you will record his behaviours. So Bruce is our very willing participant in this observational study, and he gave his time up because of a nice treat of mealworms, which is one of his favourite things to have. So when you watch the video of Bruce, these are the behaviours on the ethogram that you need to look for. The ethogram is the description and definition of behaviour, and it must be produced before your behavioural observations start. So we have 4 behaviours that Bruce performs in this video. Is he alert, being vigilant and looking around his environment, clearly with his head and neck up, scanning what's around him? Is he walking terrestrially or using his 2 feet around his enclosure? Is he sitting, which means he's in sternal recumbency, he's sitting on his tummy, on the ground. He's not asleep, he's not resting. but he is sat down and not moving. And is he foraging? Is he pecking at the ground, either on various substrates, to look for potential food items? And he might be foraging while standing or sitting down. And this last point is important because I mentioned to you that animals can only do one thing at a time. So you wouldn't record foraging and sitting, for example, or you wouldn't record foraging and standing. You either have a description that says foraging while sitting or foraging while standing, or you tell the observer that foraging is important and it doesn't matter whether the animal is sitting or standing for performing that behaviour. So by the end of our 7-minute video, we will have 7 data points that tell us about Bruce's time activity during that observation period.
Okay everyone, Bruce is about to appear in the next part of the video, which is 7 minutes long. There are instructions embedded into the video that tell you when to record behaviour on the minute intervals. Get yourselves a pen and paper, something to scribble on. Make sure you're familiar with the ethogram of alert, walking, sitting and foraging. And these are our state behaviours, our long duration behaviours that we would put into our time activity budget. Remember, don't start recording at time 0. You wait until the first minute and then you note down the one behaviour that you see Bruce doing. Have a go, see what you get, and then follow the instructions in the remainder of the video which go through each minute point in turn and will clarify for you how these data get presented in a time budget. Happy goose watching.
Let's look at our data then. You've watched the video, and what you can see are particular state behaviours, these long duration behaviours that Bruce has performed that have been recorded on 1 minute intervals, and we are assuming that that is the behaviour that takes up the full minute duration. That would be a good discussion point when you write up any research that has been based on behavioural data collected by time point sampling, because not necessarily was the same behaviour performed for the whole minute, but you are assuming that is the case. So is there any bias or margin of error? Anyway, that's for another day. What did we see Bruce doing? At minute 1, we saw he was walking. You can see that from the screen grab. 1 foot is on the floor, 1 foot is raised, he's walking forwards. How about on minute 2? Bruce is alert, he's looking around, watching what is going on around him, and you can see that from his head and neck carriage. Again, at minute 3, Bruce is doing the same behaviour, he's got the same posture. Once again, he is alert. So that is the behaviour we would have recorded at minute 3. Next up, he is still doing this behaviour at minute 4. You can see he's looking around his surroundings. And this would be something that we could consider again in a discussion. Is it because there are other birds present and there's a valuable food resource that's been scatter-fed? Bruce wants to see where the food is, but also where the other animals are and where they might be foraging. So if you were going to discuss this behaviour later, that environmental and social context would be really important. But for this activity, at minute 4, Bruce was alert. We have a change in behaviour at minute 5. Bruce has sat down and he's pecking the ground. So remember our definition of foraging. He can be standing or sitting, but he must be interacting with the substrate around him. So at minute 5, Bruce was foraging, as you can see from the screenshot. At minute 6, Bruce has just sat down. His head and neck are not raised up. He's not actively scanning the environment. He's just sat there. I don't know why, perhaps waiting to see what other birds might be doing around him before he moves on to a new behaviour. So this behaviour at minute 6, Bruce is sitting. And our last behaviour in this 7-minute observation period, Bruce goes back to foraging. He's pecking at the substrate, looking for any tasty treats that have been scattered. So the last behaviour at minute 7 is foraging. When we collate all of our behavioural data together, we find that we have 1 minute of walking, 3 minutes of alert, 2 minutes of foraging, and 1 minute of sitting. So you can see that 1 plus 3 plus 2 plus 1 equals 7, which matches our observation time. Now, obviously, this is only a very small scale investigation, but we would put this together. We would create a time budget that you can see in my bar chart there. We'd have our time in minutes on the y-axis, our state behaviours on the x-axis, and we would present the amount of time our focal individual, Bruce, the time he spent on those behaviours. So this time activity budget is really useful because it tells us this is the amount of time spent on behaviour. Time equates to motivation, motivation equates to energy, so we can get an idea of both the physiological and psychological drivers of behaviour. So we like a time budget. They tell us a lot about how animals are engaging with their environments, both physically and socially, and how they're motivated to perform particular behaviours. So know your ethogram, know your recording schedule, know your individual, and then create this form of data output once you have collected your data from your observations. In this example, Bruce was easy to follow. He was the only one of his species in that flock of birds. But what if you have multiple animals that you need to follow? What if you were out in the field, for example, in Bulgaria, where red-breasted geese occur naturally, and you needed to do a time budget of wild birds? Well, you can still apply the same process, but rather than following the individual and recording behaviour at each time period, you would count the number of birds doing the behaviour at each time period. So here in my stepwise chart, we have a count of the number of individuals. Based on your ethogram, what behaviours are they performing at each minute sample point? You would then add up the total number of individuals seen performing that behaviour across each minute. You then divide that by the overall observation time. You then divide that by the number of animals in your population. So it's important to get a handle on how many animals are there. And then you multiply that by 100 to give you the average time spent on behaviour. And the word average is really important here, because if you then go to present those data graphically, so you have average time spent on state behaviours, and you put those into a bar chart, you need to include standard deviation or standard error bars, depending on the type of average presented, mean or median, to show the reader there's variation around how all of the individuals contributed to that average data point. So still do your point sampling, minutes in an hour, for example, but count how many animals you see performing that behaviour, add up the number seen for each minute, divide by your overall observation time, divide by your total number of animals, and then multiply by 100. Here is our population of geese out in the wild. So let's do a worked example of what we said when we have to count the number of individuals because we can't identify them individually. This is our flock that we're going to follow. We've got 10 birds and we're going to do the same 1-minute samples, but this is for a 15-minute period. Perhaps we were moving around different sections of the flock every 15 minutes to sample as many geese as possible. So 10 geese, 15 minutes, 1-minute intervals for recording behavioural data. We're going to choose the behaviour alert just because we can see it's quite commonly exhibited in this photograph. So imagine by the end of your 15 minutes of observations, you had counted 56 birds, i.e. we've had 56 observations of animals being alert. So we need to calculate our average time spent on alert. So that would be dividing the 56 occurrences, the 56 counts, by the overall observation time. So 56 divided by 15. We will then need to divide that by the population of geese in our sample. So that's 10. And then we need to create our percentage for activity budget. So we multiply it by 100. So 56 observations of alert divided by the 15-minute observation time is 3.7. 3.7 divided by the 10 geese, because that's our population we were watching, is 0.37. And 0.37 multiplied by 100 gives us the average of 37% as our time that we would put into an activity budget, that the average red-breasted goose in 15 minutes in that particular flock spent on being alert. And then we would consider looking at our raw observations for each minute, and we would use that to create our error bars of standard deviation or standard error, depending on what you wanted. So this is my little worked example of what do you do to get your times on your state behaviours when you're not following an individual, when you have a group of animals that you need to record data on as counts on each minute sample. There's a whole raft of information out there, as I've just said, that will explain this in more detail. I really recommend the Bateson and Martin Measuring Behaviour book, but also there's some really nice journal articles that go into the methods and approaches for the collection and interpretation of behavioural data as well. So a big thanks to Bruce for his willing participation for a couple of mealworms in this little how-to guide. I hope you found it useful, and I hope it gives you the confidence to create an ethogram to understand state behaviours and then to record state behaviours at the individual, focal, and the group scan level, and then to develop an activity budget from those observational data. Thank you very much for listening.